this is the first part of 8.8D, and this unit is starting angle relationships. So we're going to be dealing with angle relationships in 3 different situations. The objective is going to stay the same. We're just going to kind of break it into 3 different parts to cover each part by itself. So the objective is to use informal arguments to establish facts about, well, tomorrow we're going to do the angle sum and exterior angles of triangles. Later on, we're going to do the angle-angle criterion for similar triangles. But today, all we're worried about is the angles created when parallel lines are cut by a transversal. The angles created when parallel lines are cut by a transversal. So before we move on, go ahead and make sure that you have your heading. Put today's date as the due date, and you're going to need 3 stamps today. You'll notice that there are only 3 problems, but by the time we finish these notes, I think you will be fine to do those on your own. So, this whole first page is notes. So the first thing we need to do is fill in these blanks. And the rule states that if 2 parallel lines and the parallel lines here are A and M. If they are cut by a transversal, that's a weird word, but we'll talk about it. A transversal is just a slanted line that crosses 2 parallel lines. That's all it is. You don't really need to memorize that definition or anything like that. All you need to worry about is the relationships in these between these angles. So let's scooch on down here. We're just going to talk about some rules. Notice that the angles are numbered. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to use those numbers to help us identify some examples of each type of angle. Notice that down here I've put a website. This is a really good website that I use to kind of help myself refresh the types of angles that we have between these parallel lines. So feel free to go to that website if you need some extra help. So the first thing we're going to talk about are alternate interior angles. Alternate interior angles. And I actually decided I want to go ahead and show you this website, so we're going to include that as part of the video here. First of all, it tells us about a transversal. A transversal is a line that intersects 2 or more lines in the same plane. So basically, we're only going to worry about it right now when it's crossing 2 parallel lines. When lines intersect, angles are formed in several locations. And if you look at your paper, you see that we have 8 different angles just formed by these 2 lines being intersected. Certain angles are given names that describe where the angles are located in relation to the lines. And these names describe angles whether the lines involved are parallel or not, but all we're going to worry about are parallel lines. So let's look right here. The word interior means between the lines. So interior angles here would be right here, and right here, right here, and right here. So if we flip back over to our paper, our interior angles would be 3, 4, 5, and 6 because they're between the lines. Exterior angles are outside the line. So up here and down here, or on our paper, 1 and 2, and 7 and 8 are outside the lines. So interior is between the lines, exterior is outside the lines. Okay, so let's talk about alternate interior angles. The word interior tells where they're located. It means that they're in between the 2 lines, and they're always going to be equal. So let's flip back over to our paper. Alternate interior angles aren't equal. And one example of that would be 3 and 6. Okay, the word alternate means that they're on the opposite side of the transversal line here. So 3 and 6. Another pair would be 4 and 5. So they're alternate because they're on alternating sides, and they're interior because they're in between the two parallel lines. 3 and 6, and 4 and 5. And you can tell kind of just by looking at them that they look equal, and they really are. Okay, the next thing that we want to look at are alternate exterior angles. So let's just go back over here. It's going to be the same situation, and they are also equal. So alternate exterior angles are equal. Again, they're going to be on opposite sides of this transversal line, and they have to be exterior. So 1 and 8, those are equal. And then also 2 and 7. Notice that they are both pairs are outside the parallel line, so they're exterior, and they have one on the left and one on the right of that transversal line. Okay, now let's flip over and look at corresponding angles. And the guy who wrote this website, he did a really good job, and he says, unfortunately, the name of these angles does not clearly indicate where they are located. So they can be, they're on the same side of the transversal. There can be one interior and one exterior, and they're not adjacent. That's the only thing that we know. So, for example, he tells us that on this picture, 1 and 2 are corresponding angles. 5 and 6 are corresponding angles. So notice that 1 is exterior, 2 is interior. And then 5 is interior, 6 is exterior. So they don't have to be both interior or both exterior, because the name doesn't tell us anything like that. So again, we have a situation where these are equal. Two and 6 go together. Those are equal. 4 and 8 are also equal. But we have some more too. We also have 1 and 5. And 3 and 7. So basically, corresponding just means that, kind of like in a triangle, corresponding angles are the angles that are in the same position on one triangle and the other triangle. Here, the corresponding angles are in the same position. So 2 and 6 are in the same position. 3 and 7 are in the same position. So that's how we know that they're corresponding. Next, we have interior angles on the same side of the transversal. Okay, so the word interior just describes where they are. So if they're on the same side of the transversal, that means that it's either on the right side over here or on the left side over here. On this example, angle 1 and angle 2, okay, they're both interior, and they have to add up to 180. They have to be supplementary. Angle 3 and angle 4 are on the same side of the transversal, and they have to be supplementary also. So we're going to say that they are supplementary, which means that they add up to 180 degrees. Just as a reminder. Okay, so they're interior, which means that they have to be between the lines. 4 and 6 That's one pair. And then 3 and 5 is another pair. So they're supplementary, which means that if 4 was 110 degrees, then we would know that 6 has to be 70 degrees. So anytime we're dealing with figuring out these angles here, it's really just like a puzzle. Vertical angles. This one's my favorite. First of all, they're always equal. But I like the word vertical because it starts with a V. Okay, I like this V right here. They're going to be equal. But vertical angles are like opposite of each other. So 2 and 3 are vertical angles. And if you look at this, it makes a V right here when it goes over to the other one. So that's why I like that. So 2 and 3 are vertical angles, and they're equal. So if this was 60 degrees, 3 would also be 60 degrees. 1 and 4 are vertical. 6 and 7, and then 5 and 8 are all pairs of vertical angles. And the last thing we're going to talk about is angles that form a linear pair, which we just call them adjacent angles. So adjacent angles, this means that they make a straight line. And we know that anytime something makes a straight line, then it has to be supplementary, which is 180 degrees. So we just look at everything that possibly makes a straight line. So 1 and 2 make a straight line, so those two would have to add up to 180. 2 and 4. 3 and 4. And then 1 and 3. Then we jump down here, 5 and 6, 6 and 8. We have 8 and 7, or 7 and 8, and then 5 and 7. So any two angles that make a straight line that are next to each other, so together they make this straight line, then they have to be supplementary. They have to add up to 180. So I just want to go over these really quickly one more time. Alternate interior angles are things like, let's just do some color coding here, 3 and 6. Okay, so they're on opposite sides of that diagonal transversal line. And they're on the same, they're both inside the parallel lines. Alternate exterior angles are on opposite sides of this transversal, and they're both outside the parallel lines. Corresponding angles, they're just in the same place. So for example, I'm going to have to start reusing some of these. 2 and 6. Interior angles, find my green. Let's do 3 and 5. They're on the same side of the transversal, but inside the parallel lines. Vertical angles are the ones that make that V. I'm going to use 1 and 4. And then adjacent angles are right next to each other and make a straight line. So I just circled one example of each type. don't know if that helps or not, but you're now going to do number 2, 6, and 1. If you get stuck, see what you can narrow down first. See what you can get rid of, and then try to choose more easily between remaining answers. If you bring it to me and it's incorrect, then we can talk about it if you have questions. So you're going to do 2, 6, and 1 on your own. You can bring me your paper in between each question if you want to, or you can do all 3 and then bring it up to me. And then those are the only 3 problems that you have for today's assignment.